Let us look at indifference set and indifference curve. Suppose a consumer likes all the combinations of apples and oranges given in this table equally, because each combination gives him the same level of satisfaction. In combination A, the consumer has 1 apple and 10 oranges. In combination B, he has 2 apples and 7 oranges. In combination C, he has 3 apples and 5 oranges. And in combination D, he has 4 apples and 4 oranges. An indifference set is a set of combinations of 2 goods that gives the consumer the same level of satisfaction. Therefore, the consumer is indifferent among all these combinations. Now, let us plot these combinations on a graph. Apples are shown on the x-axis, and oranges are shown on the y-axis. When we plot combinations A, B, C, and D and join these points, we get an indifference curve. An indifference curve is the diagrammatic presentation of an indifference set of a consumer. Therefore, every point on the indifference curve represents a different combination of apples and oranges that gives the consumer the same level of satisfaction. Let us now look at the features or properties of indifference curves. The first property is that an indifference curve slopes downward from left to right. In other words, an indifference curve has a negative slope. Let us understand this using the graph. At point A, the consumer has 2 units of apples and 5 units of oranges. Now, suppose the consumer moves from point A to point C. The quantity of apples increases from 2 units to 3 units, while the quantity of oranges decreases from 5 units to 3 units. So, if the consumer wants to have more of one of the goods, he must give up some quantity of the other goods to remain on the same indifference curve. Only then will his level of satisfaction remain unchanged. We can also see this mathematically. The slope of the indifference curve is delta y divided by delta x. Here, the change in oranges is -2, while the change in apples is +1. Therefore, the slope is -2 divided by 1, which is equal to -2. Hence, an indifference curve has a negative slope. Let us look at the second property of an indifference curve. An indifference curve is convex to the origin. This means that the slope of the indifference curve tends to decline as we move along the curve from left to right. The slope of an indifference curve is called the marginal rate of substitution, or MRS. MRS refers to the rate at which a consumer is willing to substitute one good for another, while maintaining the same level of satisfaction. Let us understand this using apples and oranges. As the consumer moves from left to right along the indifference curve, the consumption of apples increases, while the consumption of oranges decreases. As the consumer gets more and more apples, the marginal utility of apples decreases. At the same time, as the consumer has fewer and fewer oranges, the marginal utility of oranges increases. Therefore, the consumer is willing to give up smaller and smaller quantities of oranges to get additional apples. For example, when moving from point A to point B, the consumer gives up 1.5 units of oranges to get 1 additional unit of apples. From point B to point C, he gives up 1.5 units of oranges to get 2 additional units of apples. And from point C to point D, he gives up only 0.5 units of oranges to get 2 additional units of apples. Therefore, the absolute value of MRS decreases from 1.5 to 0.75 and then to 0.25. This is called diminishing marginal rate of substitution. Hence, an indifference curve is convex to the origin because MRS diminishes as we move from left to right along the curve. Let us now look at the third, fourth, and fifth properties of an indifference curve. The third property is that as an indifference curve moves away from the origin, the level of satisfaction increases. In other words, a higher indifference curve represents a higher level of satisfaction. Let us understand this using points R and S. Point R lies on IC1, while point S lies on IC2. At both points, the consumer has the same quantity of oranges. However, at point S, the consumer has more apples than at point R. Therefore, point S gives the consumer a higher level of satisfaction than point R. The reverse situation is also possible. Therefore, an indifference curve farther away from the origin represents a higher level of satisfaction. Let us look at the fourth property of an indifference curve. Two indifference curves cannot intersect each other because this would lead to a contradiction. Let us understand this using the figure. Points A and B lie on IC1. Therefore, A and B give the consumer the same level of satisfaction. Similarly, points A and C lie on IC2. Therefore, A and C also give the consumer the same level of satisfaction. This means that B and C should also give the consumer the same level of satisfaction. But this cannot be true. Points B and C have the same quantity of oranges, but point C has more apples than point B. Therefore, point C must provide a higher level of satisfaction than point B. This creates a contradiction. Hence, two indifference curves cannot intersect each other. Let us look at the fifth property of an indifference curve. An indifference curve does not touch either the x-axis or the y-axis. This is because indifference curve analysis considers the consumption of two goods simultaneously. In our example, the two goods are apples and oranges. If the indifference curve touches the x-axis, the consumer would have some quantity of apples, but zero oranges. Similarly, if the indifference curve touches the y-axis, the consumer would have some quantity of oranges, but zero apples. In both cases, the consumer would be consuming only one of the two goods. Therefore, an indifference curve does not touch either axis.